All right, let's talk about a couple of things called relative error and propagating error. This is from section 2.6 from your book. And so we're still going to be converting between some measurements, but now we're going to go ahead and scale to two-dimensional and three-dimensional objects, so things with area and volumes. And we're going to talk about relative error, also known as percent change, also known as percent error, also known as relative change. So these, a combination of these can be used interchangeably sometimes, and often are. I put the conversions again in your notes just for convenience. Okay, a couple of recalls. Or maybe you're thinking that this is the first time you've seen it, but nonetheless, recall. Change. I think I might have put this in the percent section. Change is the new amount minus the original amount. Oh, and the signed number section too. Because I remember telling you that if you switch the order of these, it will definitely have a different indicator. Because if suppose some amount had gone up, for instance, taxes on, I don't know, insert a vice here, cigarettes. So the new amount of tax minus the original amount of tax would be a positive number because it's gone up. But if you accidentally swap these and put the original tax, take away the new tax, then you would get a negative number, and that would say that it was going down, but that would not be accurate. So the amount of change is how much it is compared to how much it was before. So the difference between the two. And then percent change, we have also talked about. Okay, and that is a ratio of the change to the original amount. So, and your book says this too. They write it as the ratio, the change compared to the original. Okay, and so ultimately you would use this, you would use new amount minus original amount to find this numerator. So you would find the difference, and then you would compare that to the original amount in order to get percent change. And of course, more often than not, this will give you a decimal, and we scale it up by 100 to turn it into a percent. Okay? All right, let's take a peek at this. Comparing winnings and debts. A person wins 20 bucks and gets to keep 10 of it. Find the difference in the amounts, then find the relative difference, aka also known as the percent change. So just so that we're crystal clear, this is saying, so percent change, also known as relative difference, relative error, relative, okay, sure. Relative change. That's also another way. So here we go. Let's see. So first, original amount was 20, gets to keep 10. Okay, so find the difference in the amounts. All right, so so here we go. Let's go percent change. All right. They won 20. They kept 10. So the new amount, 10 bucks. Originally, the winnings were 20 bucks. And we are comparing that to the original winnings of 20 bucks. Okay, and I'll put this percentage part of it. All right, well, 10 take away 20 is negative 20. And 10 take away 20 is negative 10. We're down by $10. And negative 10 divided by 20, well, 10 20ths is a half. 10 is half of 20. So this would be a negative half. Okay, but then scaled into a percentage. Okay, so the percent change or the relative difference is down by 50%, which makes sense, right? They won 20, they only got 10 of it, so they got half of it. A person, it's almost like losing half. Loss, even though it's winnings. A person wins 5 million and gets to keep 4,999,000. Find the difference and then find, oh, wait a minute. I should have done that here too. Find the difference in the amounts and then the relative. Okay, hold on. So here's the relative difference, the percent change, but the difference was just the pure change, which is this numerator. So the difference, the change, $10, take away $20. Those are like terms, down by $10. Yeah? Okay. Now a person, the difference here is more actually. So the change in this situation is that they're keeping this, but originally they won 5 mil. So 400,999,000, take away the original 5 million. And that is a loss of what, $1,000? Okay, loss of $1,000. But when I think about these, let's go ahead and put the percent change and then answer which one is more significant of a change. So let's see here. Percent change or the relative difference. Okay. So the change here we've already computed. That's the numerator. So the change is down $1,000 compared to the original of 5 million. And then scale it up to be a percentage. I mean, 1/5,000th. Okay, hold on. So let's see. I'm going to go ahead and do this division. And then multiply by 100. I get 0.02. Let's see. Okay. So the percent change is much, much smaller. This one was down by 50%, and this one was down by 0.02%. Which of these scenarios is the shortage significant? In which one is the shortage significant? So when I look at the actual change, right? So if you look at the actual change, right? $10 lost versus $1,000 lost. That feels really significant because you lost $1,000, and losing $1,000 is way more than losing $10. Except for the fact that in the second scenario, yeah, but you still got 4,999,000. So do you really care about that grand? Do you? I doubt it. So, but here, someone wins $20 and loses half of it. Yeah, that matters. That's like a whole 2 gallons of milk or whatever. So, maybe 3. So in which of the two above scenarios is the shortage significant? You could make a claim that $1,000 lost is more significant than $10 lost, but at the end of the day, because of how much is overall there, the $10 loss is actually more significant of a loss because of what they had won. So you shouldn't just take into account what's lost and what was won, or without taking into account what was won. Should I say that again? You shouldn't take only the loss into account without also including how much was actually won. It matters. So if I rewrite this as $10 won versus 4,999,000 won, I mean, that is a huge difference. Okay, so at the end of the day, which was the shortage more significant? The 50% shortage was a more significant loss. Okay? So this percent change, or this relative difference, or this relative change, or this relative amount, relative quantity, I think they're going to call it in Math 104, Gen Ed Math. You got to take in each of these things into account. And this is this is a very telling measure to see how drastic it was compared to the original amount. All right, let's look at the federal deficit. In 2011, it was about $1.298 trillion, meaning the U.S. spent $1.298 trillion more than it brought in the year 2011. Suppose you round that up to $1.3 trillion. What is the significance? What is the difference or the change? And what is the relative error or the percent change from rounding? All right, let's compute. Let's go green style, why not? Or we could go red for deficit, but whatever. Let's see. So first, let's just find the actual difference. So the change, okay. So the new amount is 1.3. So I'm going back to this up here. The new amount is 1.3 because that's what we rounded it to. The original amount was 1.298. So 1.3 trillion minus 1.298 trillion. Okay, and let's see how many, what is that? Tenths, hundreds, thousandths, 2 thousandths off. Okay, but trillions. Okay, and so because of that label, which notice that I've included the units here, I'm actually going to write that out in dollars. Let's see. Let's go, so we go hundred, thousands, so we got thousands, tack on 3 more zeros, million, tack on 3 more zeros, we've got a billion, tack on 3 more zeros, and we have a trillion. Oh man, that's a lot. I don't think I'm going to have enough room to actually write this number. Here we go. 2 and okay, hundreds, thousands, millions, 20 billion. So that was a difference. So rounding this to 1.3 trillion, yeah, that just cost us $20 billion. Okay. Let's see. And then it says find the relative error, or how, so if you round, you are incurring error. So that's why it also gets the name, it gets the name relative difference because it's the change, percent change. Relative error, how much was the error? Relative error. Okay, so we're going back up here to this change, ratio of change to the original times 100 to turn it into a percent. Relative error, change. Should we write it in terms of, let's just go back to the labels. The change was 0.002 trillion compared to the original, which was 1.298 trillion. Okay. I am doing this on my calculator in case you're thinking, what? Okay, this is a rounded amount. Okay, and when you do that division, you get approximately 0.154%. So about 0.154%. Okay, so in terms of, I mean, relative to how huge this deficit is, I mean, it's a tiny amount of error, but this tiny amount of error, because these units are so huge, means it's 20 billion bucks. Okay, so just keep in mind that when we're looking at these, the ratio of amounts, we're really looking at a comparison, because this number is so huge and that number is so huge, the difference wasn't that significant. Okay, the error, yeah, we had some error, but not a lot. Not even one full percent, actually. 0.15, not even 0.2 or 1/5 of a percent. But that was $20 billion. In the next example, in the next video, we're going to carpet a room. Okay, we're going to carpet this room. And we are going to talk about, we're going to use conversions. We're going to see what happens when we round. We're also going to have to remember some of our geometric formulas. Okay, so in the next video, we'll go ahead and tackle example 2, carpeting a room.